Okay, so we now have lesson 8.3. In lesson 8.3, we're going to be learning about matrix operations and how we can apply them to certain types of problems. Our learning intention, we will learn how to conduct operations in matrices and how they can be applied to pixel images and transformations of an image. Now, the things that I want you to be able to do by the end of this video are that you're able to read and use matrix notation. You can confidently add and subtract matrices. You can multiply a constant to a matrix that's called scalar multiplication. You can confidently use technology to multiply matrices. I'm actually going to let you use your calculator. And I am able to apply these operations towards pixels and transformation of images. So real quick with matrix notation, all right? Just something to keep in mind is that capital letters denote the matrix, so when you see this, you know capital A is matrix A. Now, the lowercase letters are used to denote the element within the matrix. Now, the element is just the numbers within the matrix, okay? Now, when you see A and then IJ, the I represents the row number, and J represents the column number. Remember, columns hold up buildings, so columns are up and down, rows go across. And then, besides being able to figure out the element of a matrix, I want you to also be able to know the order. Now, the order of the matrix is going to be M times N, which M is the rows, and N is the columns. So, let me, real quick, M is the rows, N is the columns. Alright, now just a little fun fact, if your rows and column numbers are the same, you have the same number of rows as columns, like a 2x2 or a 3x3, it's called a square matrix just because it is perfect dimensions, both columns and rows. We're going to be using square matrices a lot when it comes to 8.4 when we're going to be doing some coding kind of things, so just something to keep in mind. So, let's look at example 1, matrix notation. So we have matrix A, 3, 2, 0, negative 4, negative 5, negative 1/2. Now, what is the order of this matrix? Well, remember, it goes row by column. So I have, how many rows? I have 2 rows. And I have 1, 2, 3 columns. So it's a 2x3. Now, when we get to, so that's just the order. Then when they ask us stuff like identify A23 and A12, since it is a lowercase, they're talking about what number within matrix A falls in 2, 3. Talking about row 2, column 3. So if we look row 2, column 3, I see negative 1/5 is there. Now for A12, meaning row 1, column 2, row 1, column 2, I have the number 2. So that's how we can figure out different pieces within a matrix, our elements and everything. So what I'd like you to do right now, pause the video and try out checkpoint 1 on your own. Okay, so what is the order of matrix A? Well, now we have 1, 2, 3 rows and 2 columns. So it's a 3x2. Now, when we identify A12, remember that means row 1, column 2. That's negative 2. And then A31, we're talking about row 3, column 1. And that's the number 1. So that's just kind of a little like introduction to figuring out size as well as specific elements that we would like to identify. Those would be kind of multiple choice questions. Now, equality of matrices, okay, something to keep in mind, which this does make a lot of sense. 2 matrices are equal if and only if they have the same order and corresponding elements, okay? So they gotta have the same size and all the elements have to fall in the same spot. Alright, so for example, if I gave you something like this, okay, if matrix A equals matrix B, then A is going to equal B. Matrix A and B will be the same if and only if what happens? Well, if I look at my matrix, well, X is going to have to be 1. Then Y plus 1 has to be 5. So that means Y's got to be 4. And then Z has to be 3. And then we know we're good because of 6 and 6, so that's totally fine. That would be another kind of multiple choice style question. Now, adding and subtracting matrices, okay? We can only add and subtract matrices with the same order, okay? For adding or subtracting anything, we always need them to have something in common. For polynomials, we add like terms, fractions, common denominators. The list goes on. So with matrices, I am going to add matrices if they're the same size, and I'm going to add numbers that fall within specific spots. So, for example, all right, in example 2a, they're both 2 by 3, so I can add them. And what I'm going to do is I'm going to add everything that falls within the corresponding spots, okay, that align. Oh, hold on. 3, 3, 3 and 5. -2, 7, 6, and -9, and then the -8 and 6. Okay, so when I go to write this, 0 plus -2 is -2. 5 plus 3 is 8. 3 plus 5 is 8. Then -2 plus 7 is 5. 6 plus -9 is -3. -8 plus 6 is -2. And that is going to be our answer. Now, when it comes to subtraction, this is the big thing I want you to kind of take into consideration, okay? We need to know that when we're minusing, think about when you did something like 3x plus 5 minus 7x minus 2, right? You first distributed the negative, so it was really minus 7x plus 2, right? And then you combine your like terms. So what I want you to do, kind of that same concept, I want you to take this minus and make it plus and switch all the signs inside. Now you don't have to switch the sign of 0 because 0 positive or negative, it's still the same. 0 is neutral. So just make sure you switch all the signs with it. I would suggest doing that in another color, or you could circle and then change it up top. And now I'm going to combine all the ones that line up together. So -6 plus 5, 7 minus 6, 2 plus 0, and then -3 plus 4. So I'm going to have -1, 1, 2, 1. And that's adding and subtracting matrices. Okay? Remember, only add or subtract when we have the same order. They got to be the same size, or else we can't combine all the pieces within every element. Try checkpoint 2 on your own and see how it goes. Alright. Remember, pause if I'm going too fast. Alright, but for now, so we got a 2 by 2 and another 2 by 2, so I can add them. I'm going to add everything that falls in corresponding spots. So -4 plus 6 is 2. 3 plus -3 is 0. 7 plus 2 is 9. -6 plus -4 is -10. Now over here for the subtraction, first thing we have to do is change this to a plus and change all the signs. We don't have to change the 0 because it's neutral. And now I'm going to combine. Okay, because remember they are both 3 by 2s, so I can combine them. 5 plus 4 is 9. 4 plus negative 8 is negative 4. Negative 3 minus 6 is negative 9. 7 plus 0 is 7. 0 plus 5 is 5. 1 minus 3 is negative 2. Okay, so that's adding and subtracting. Now, something to keep in mind, all our properties with addition and subtraction normally are commutative, which switching the order doesn't matter. The associative, additive, identity, all that stuff, it still works. It doesn't matter. Now, besides adding and subtracting, we can multiply something to a matrix, okay? Talking about just multiplying a scalar, a single number, all right? We already kind of been doing that when we try and get rows to match. We multiply something to it, right? And remember, we never divide. If you want to divide everything by 3, remember you're going to write it as multiplying by your third. So, now if I like to get problems like these, now make sure you're writing down the right matrix, okay? Because I gave you 2 different matrices, and I'm asking you to use, in the first part, negative 5 times b. Our eyes instantly go to the first one. Please make sure you're writing down the appropriate matrix. So, negative 5b. So basically what I do is I want to multiply negative 5 to everything in matrix B. So I'm going to get negative 10, 15, negative 25, and 30. That's it. Now with the other one, okay, so this is A. With B, see how we have 2A plus 3B. We need to follow PEMDAS when it comes to this. Alright, I have to do the multiplication first, and then I can add, subtract, whatever I want. So 2 times matrix A is negative 1, 4, 3, 0. And then plus 3 times 2, negative 3, 5, negative 6. So I multiply everything, the 2 into matrix A and the 3 into matrix B. I get negative 2, 8, 6, and 0. And then I multiply the 3 in, and I'm going to get 6, negative 9, 15, negative 18. And now I will add. So I get 4, negative 1, 21, and negative 18. Now, something I do want you to keep in mind. If, let's say this here was a minus 3 instead of a plus 3. Multiply the negative 3 in and then leave a plus outside. Because you brought the negative in already, you leave a plus outside. If something like that ended up happening. Okay? But it didn't, so you could kind of, you don't have to worry about it. Alright? Let me just fix this a little bit. Alright. So I want you to pause the video. Try checkpoint 3. Okay. So for negative 6 times B. Alright, so I'm doing negative 6 times matrix B, which is negative 1, negative 2, 8, and 5. So we multiply everything by negative 6, and I get 6, 12, negative 48, and negative 30. And we're done with that one. Now with 3A plus 2B, 3 times matrix A, which is negative 4, 1, 3, 0, plus 2 times matrix B, which matrix B is negative 1, negative 2, 8, and 5. So I'm going to multiply first into the matrix, negative 12, 3, 9, 0. And then I'll multiply the 2 into the B, and negative 2, negative 4, 16, and 10. And now that I have multiplied, I now can do the addition. And your final answer will be negative 14, negative 1, 25, and 10. Now, I know you could plug these matrices into your calculator, all right? But one thing I really want you to realize is that sometimes, especially with addition, subtraction, multiplying a scalar, it is so much faster to just do the work on paper than it is to spend the time typing it into your calculator. Because you make one little mistake typing it into your calculator, it messes up everything, okay? I'm going to show you, I know some of you already know how to type it into the calculator, but if not, I'm going to show you when we talk about multiplying in a second. So what we are going to do is we're going to move on to, oh yeah, let's do solving matrix equations first, and then we'll go on to multiplying matrices. So, alright, so solving matrix equations, alright? So I'm going to give you something like example 4. Solve for x in the matrix equation. 2x plus a equals b. I'm going to give you matrix A and matrix B. Since x is capitalized, you know that you are going to get a matrix as an answer. Alright? Now, instead of plugging in matrix A and B right away, what I suggest, follow these steps. I would first solve for the variable within the equation. Once you have that variable isolated, then substitute in your matrices and you'll save yourself a lot of hassle. So what I'm going to do first is I'm going to take this 2x plus a equals b, and I am going to get x by itself. Alright, so first thing I'm going to do is minus a to both sides. Now notice how I'm leaving everything capitalized because they gave it to me as a capital. Remember, they are matrices, so they need to be capitalized. You cannot write them lowercase because then technically you're wrong. Okay? So I minus a, and now I got to divide by 2. However, remember, we don't write division in matrices. We do multiply by the reciprocal. So I'm going to multiply both sides by a half. And matrix X is the same thing as 1/2 times B minus A. Okay, so that's the first step. Solve for the variable itself. Now what I want you to do is actually plug in your matrices. So it's going to be 1/2 times matrix A, which is 1, negative 5, matrix B, B minus A. Okay, matrix B is negative 6, 5, 9, 1. Order does matter. Minus matrix A, which is 1, negative 5, 0, 2. And now it's any problem we've done before. So since it is minusing, I got to change this to a plus and change all the signs in here, except for zeros. And now I'm going to actually do the subtraction. Negative 6 minus 1 is negative 7. 5 plus 5 is 10. 9 plus 0 is 9. 1 minus 2 is negative 1. Then last, I'm going to multiply everything by a half. And I'll have x equals negative 7 halves, 9 halves, 5, and negative 1/2. You could have also written it as either one. Negative 3.5, 4.5, negative 0.5, and 5. I'm fine with that because if you actually do the division, you get an exact answer. It's not like you had to round those fractions. If it was a third, I would rather you leave a third because with a third you have to round. Okay? If it doesn't go on forever, you go write down the decimal. If not, leave it as a fraction. Just simplify the fraction. Okay. Try checkpoint 4, and then we'll move on. Okay, so it says 3x plus a equals b. So I'm going to minus a to both sides. And then I'm going to divide, well, wait, no dividing. I'm going to multiply both sides by a third, same as dividing by 3. We get x is 1/3 b minus a. Okay, so we have to do b minus a first, and then we will times it by a third. So I'm going to rewrite this. X equals 1/3 parentheses. I have my matrix B, which is -10, 1, -9, 17, minus matrix A, which is 2, -8, 0, -4, +4. And now I'm going to change the signs. This has to be plus, this is minus, this is plus, this is minus. I need to make an addition before I add. And then I get x equals 1/3 times, what matrix do we have? -10 minus 2 is -12. 1 plus 8 is 9. -9 plus 0 is -9. 17 minus 4 is 13. Multiply everything by a third, and I'm going to get -4, 3, -3, and then I'm going to leave 13 over 3. Okay, I know it's 4.3, but the 3 goes on forever and ever. There's no end. So you have to leave it as 13 over 3. Okay. Now I want you all to have your calculators out so that we can go on to multiplying matrices, okay? Now, again, I'm going to show you it is very annoying to plug the matrix into the, into the calculator. It does take a lot of time, so I really, really, really need you to do this check first. It'll actually save you a lot of time, okay? When we're multiplying matrices, okay, I need you to know that order matters, okay? Because if you switch the order, you could get a completely different answer, all right? Now, what is this whole like kind of these two must match, the order A, B? I'm going to show you within the next problem, okay? So I always want you, this is the check. So we want to do, for example, 5, A times B. Well, matrix A is a 2 by 2. Matrix B is also a 2 by 2. So what we're going to do before we actually multiply, I want you to first check the inside numbers, okay? First check the inside. These must be the same. That's what we were talking about up here, okay? The two inside numbers have to be the same in order for you to multiply. If they're not, then your answer is no solution, okay? But luckily here, 2 and 2, they do match, okay? Now the two outside numbers, that's actually going to be the size of your answer, okay? So when I do A times B, it's actually going to be a 2 by 2 as well, all right? So what we're going to do now, I'm actually going to plug all this in my calculator because I could actually multiply. All right. So in order to plug this in your calculator, the first thing I'm going to do, all right, here, let me make this a little bigger.